Now the next topic is Laplace transform of derivatives. Then this, if you know this Laplace transform of derivatives, then we can apply these formulas in applications of differential equations. Means while calculating the solution of the given differential equation, Laplace transform, these formulas are very helpful. Now how to understand this concept? Please. Laplace transform of f of t equal to f bar of s. This is known thing. If you know Laplace transform of f of t, unknown function, given function, equal to f bar of s, easily we can calculate it. Then Laplace transform of first derivative of f of t, f dash of t equal to, what is the formula? S into f bar of s minus f of 0. What is that formula? Laplace transform of f dash of t means first derivative of f of t equal to, formula is s into f bar of s minus f of 0. This is the formula, direct formula. Then f bar of s is known quantity and multiply with s, and f of 0 means t equal to 0, you calculate f of 0 and automatically we can calculate Laplace transform of first derivative of f of t. Means like this we will calculate it. Next one, in the Laplace transform of double derivative of f of t, means Laplace transform of f double dash of t equal to s square into f bar of s minus s into f of 0 minus f dash of 0 minus f dash of 0. This is the formula. General formula by using this technique. The general formula is Laplace transform of nth derivative of f of t, means f power n of t equal to s power n f bar of s minus s power n minus 1 into f of 0 minus so on f power n minus 1 of 0. Then these are the important formulas, Laplace transform of the derivative of the given function. Like this, by using these formulas we can calculate very easily, and these formulas are useful solving the differential equation. In the same way, another one, Laplace transform of integrals. Now here also the statement once again, Laplace transform of f of t equal to f bar of s. Laplace transform of f of t equal to f bar of s. This is known thing. Then Laplace transform of integral 0 to t f of t dt, integral 0 to t f of t dt equal to f bar of s by s, f bar of s by s. Suppose same way, suppose Laplace transform of integral 0 to t f of t dt, two times integrations are there, then f bar of s by s square. This is the formula. In the similarly, integral Laplace transform of integral 0 to t n times f of t dt like that, then dt n times, then the answer is f bar of s by s power n. This is the Laplace transform of integrals. Now very simple, suppose if you want to calculate Laplace transform of integral 0 to t square dt. Now observe this one, this is example, Laplace transform of integral 0 to t square dt. Then integration Laplace transform of integral of this function. Then answer is directly, no need to do the integration, the answer is f bar of s by s. What is f bar of s here? Laplace transform of f of t. Laplace transform of f of t means Laplace transform of t square. Laplace transform of t square means, what is the formula? 2 factorial by s cube. Therefore the answer is, for this total Laplace transform of integral 0 to t square dt is 2 factorial by s cube divided by s. means the answer is 2 by s power 4. Like this, we can calculate the Laplace transform of integration of this function. Now in the similarly, we can solve derivative problems also. Already I have given to you some important problems.